Okay, so our problem statement reads, assume that a, b, c, and d are positive integers such that a to the power 5 equals b to the power 4, c to the power 3 equals d to the power 2, and c minus a equals 19, and we are asked to find d minus b. So for this problem, we'll use substitution, the difference of squares theorem, and some prime factorization properties. So starting off, since we know that a to the power 5 equals b to the power 4, then we can have some integer x such that a equals x to the power 4 and b equals x to the power 5. And we know these exponents because of the given relationship between a and b. And similarly, since we know c to the power of 3 equals d to the power of 2, then we can have some integer y such that c equals y squared and d equals y to the power 3. So then we can also plug this back into the c minus a equals 19. C minus a equals 19, and then we get that y squared minus x to the power 4 equals 19. And this is where we can apply the difference of squares theorem, which is basically when you have two squares. So for example, if we had like p squared minus q squared, then this is equivalent to p plus q times p minus q. So we can move this to the side, and then applying it to this equation, we get y minus x squared times y plus x squared equals 19. And then we can define some integer or variable z to equal x squared. So we have z equals x squared. Then this becomes y minus z times y plus z, and this also equals 19. And then since 19 is prime, the only possible values of either y minus z or y plus z are 1 or 19. But since y minus z and y plus z are positive values, y minus z must equal to 1. So then we have y minus z equals 1, and y plus z equals 19. And then when we try a few integers, we get that y equals 10 and z equals 9. And if we recall, we let z equal x squared, so that means that x equals 3. Now if we plug all of this back into what we want to find, we want to find d minus b. I'll write it here, d minus b, and this equals y cubed minus x to the power 5, which equals 10 to the power 3 minus 3 to the power 5, which equals 100 minus 243, which equals 757. And that is our final answer.